we've ordered a very nice, wonderful Maine summer weather for you. If you've come from the south, this is really nice and cool for you. I know many of you have come from a long distance. Welcome to the University of Maine TIDC conference. TIDC stands for the Transportation Infrastructure Durability Conference. The conference we do every year, and we're focusing on very difficult problems our transportation system incurs in New England and throughout the country. And it is bridges falling apart. And particularly we focus on bridges. Corrosion is a big issue in our region. Corrosion because they use of salts, because we're near the saltwater environment. That's a big issue in Maine and throughout New England. So we've been doing research in that particular space with a variety of partners across New England to help solve some very tough problems. You'll hear about those in just a short while. I'd like to thank you all for coming, and I'd also like to introduce later on our keynote speaker who's here with us, Vincent Tang from ARPA-I, and Kelly right here also from ARPA-I. So we have a number of very good keynotes. Jeff from the Maine Department of Transportation. Those of you who don't know me, I'm Habib Dagher. I'm director of the Advanced Structures and Composites Center at UMaine. UMaine, if you don't know either, is a land-grant university. We've been a land grant since 1865 when the Land Grant Act was established. These universities were established throughout the country in various states, including Penn State, for example, is land grant university. University of Wisconsin-Madison is another land grant university. So we were born at that particular time. And the very first graduate from this university was a civil engineer. Most people don't really know that. So and we have a long history in engineering on this campus. We go back that far back. We have a society called the Francis Crowe Society. Francis Crowe, anyone knows who he is? Many of us, at least if you're a UMaine grad, you do. He's the engineer who's in charge of the construction of the Hoover Dam. And he was one of our graduates. And actually, he's a person of a very few words. When the president asked him to come up to the podium and introduce the Hoover Dam, he came up and said, Mr. President, distinguished guests here, here it is, what else can I tell you? So there's a lot we're going to be telling you here today about durability, particularly composite materials. Really, really glad that we have also ACMA represented. John Bissell right here from ACMA has been really bringing composites into infrastructure, essentially for as long as I could remember. John, would you mind standing up for people to recognize you and recognize what you do? And we have Joyce Taylor. Joyce, you want to stand up here? Joyce was a chief engineer at the Maine DOT, but today or yesterday, right? You became the associate or commissioner or for deputy commissioner for transportation. And but Joyce has told me she really would like to also keep a leg into the engineering. She has engineering in her heart, and so she'll be doing really two jobs: the engineering job and continuing some of that work, but also moving on to after 12 years in that chief engineer position. So it's great to have you here, Joyce, and thank you for the contributions to the state and to the nation. So. I'd like to also take a moment to thank some of our sponsors here today: VHB, GZA, TIDC, the School of Engineering and Computing, FHWA, UMaine, Maine DOT, and many others today. I'd like to also thank the organizers of this particular event: Dale Peabody, who's co-chair of this committee, who organized this conference. Dale, please stand up. Where's Dale? Yeah, there you go. Jeff Pulver, who's also co-chair of the event. Jeff, are you right here? Yeah, thank you. Jim Bryce, who everybody knows has been really the heart and soul of the Transportation Infrastructure Center. Aaron Shank. Aaron, you're here? Yeah. Aaron is the person who did logistics and communications. Jenna O'Brien, it's Jenna here. Yeah, Jenna, thank you, Jenna. Brianne Carter on the financials. Brianne, very important. And MJ on marketing and communication. MJ go through. MJ, are you here? Looks like MJ is not with us here. So the agenda today, covers, we have a very full agenda. We're going to start with some keynote addresses. You can go see it here on the screen. I'm going to go ahead and tell you a bit about the TIDC project, TIDC conference, and the center that led to this conference. So TIDC is a Transportation Infrastructure Durability Center here at the University of Maine, which was funded by a federal highway as a regional center for New England for transportation. The mission is to develop innovative, sustainable, next-generation solutions to improve durability and extend the life of existing infrastructure. As you know, that's one of our biggest problems in New England and throughout the country, particularly in northern regions where we use a lot of salts on the roads. And this has been done in collaboration with our New England states, DOTs. We couldn't have done it without them. So Maine DOT and the rest. So if you're a representative from some of the DOTs here in New England, would like you please to stand up, be recognized for really being part of this. So please stand up if you're part of the DOTs. I know you're there. It's okay. All right. Thank you very much. And the DOTs were key to the Transportation Center. They were actually reviewing ideas for projects, putting ideas forward for projects, picking projects that we should be funding across New England. So without the DOTs, we would not have done the Transportation Center we have here. So very, very much appreciated. And Dale Peabody really was pulling everybody together for many, many years. So thank you, Dale, for your continued, for the amazing work you've done along with your colleagues throughout New England. We also have partners from all the universities, many universities in New England, UMaine, UConn, University of Vermont, UMass Lowell, Western New England University. So I'd like to thank them all, and many of them are right here. They're part of our management team. If you're here, you're part of the management team. I'd like to please stand up and be recognized. So I know you're there. Yeah. So on the left-hand side, you see the DOT representatives at the Transportation Center, and then the management team. These are the universities on the right-hand side working together with the DOTs to make things happen. Next slide, please. So we have our Transportation Center focused on 4 thrust areas. And one thrust area is diagnosing bridges. Before you could figure out what's wrong, you got to figure out how to fix something, you got to figure out what's wrong. So how to go out and diagnose bridges in a better ways is a big piece of this. What kind of sensors can we put out there? How do we go and inspect bridges, whether it's using drones, for example? We've got a project on using drone technology to go out and inspect bridges, which makes it easier to do. These are examples of things we've done. The second thrust is implementing novel materials. One of the big and innovative materials we've been working on are composites. As you know, composites have an opportunity to reduce corrosion and maintenance costs of bridges. Currently, some of the costs of composites are a little bit higher than traditional materials. But when you look at life cycle costs, that's where composites really shine and allow us to reduce maintenance costs. We've done a lot of work in the composite space. If you drove up, how many of you drove up through I-95 here coming up to Orono? So when you drove up through I-95 and came up on Stillwater Avenue in Orono, you saw a big bridge being shut down. Well, thanks to the Maine Department of Transportation, they selected a composite girder technology developed as part of this Transportation Center here at the University of Maine to build potentially the longest composite bridge in the world. You know, think about it, it's happening right in our backyard right here. And it's being made and fabricated as we speak. Yesterday, I was in Winterport, Maine. There's a company that spun off our laboratory, and it's called BI, and that's Basalt International. And they're the ones actually fabricating the bridges for the Maine DOT right here in Maine using Maine labor. And these girders aren't tiny. Some of these are 95-foot long composite girders, 4 feet deep, weigh 12,000 pounds. So these are very big girders. So I'd like to thank the DOT for really investing in next generation technologies. And hopefully what we'll learn a lot from these kinds of applications to reduce our maintenance costs, not have to replace our bridges as often as we typically do. And so I'd like to take a minute to really thank people who've worked on this project. So if you're part of BI here, I know the BI leadership is here. It's here, Benjamin Tank up here. Benjamin Kim is up here. Ben, you want to come up here? Stand up here a minute. Ben came all the way from California, and he's essentially CEO of the organization, and much of his team is also here with him. So if you'd like them to all stand up and be recognized as well. So these are the folks who are actually building this bridge. And I can tell you, it's amazing. They've already built a quarter mile's worth of girders that are 95 feet long, 4 feet deep. If you haven't seen this, go and take a look what they're doing out there. Here in Maine, we don't have to import these girders, and they're going to last a lot longer. That's really what we're talking about in terms of transforming our infrastructure. And it doesn't happen without the partnership with DOTs that are willing to step up and really take some risks with new technologies like that. So thank you, Joyce, and thank you, Maine DOT, and Dale and many others for really believing in this and trying to push technology forward. So this is in terms of new materials and systems, thrust 2 and thrust 3. And the last thrust is enhanced performance through innovations in safety, resilience, and connectivity. So we'll go and give you examples of things that we've worked on. Next slide, please. So this is a bridge that we've partnered with the Maine DOT on using this composite girder technology. And you can see the girder right here is, this is a bridge that we built in the Bangor area in Hamden. It's about 70 feet long on Route 1. So it's a highway type loading. It's designed for a highway loading. But notice one thing that's happening. The contractor figured out that those girders are so light, I can pick them up 2 at a time. Now, that's an example of an advantage that you see here with this technology. Another advantage is, notice how the webs of these girders are inclined. These girders are empty, by the way, on the inside, they're hollow. There's just a stiffener here at the end. But you can stack them together, you can nest them together on a truck and ship a lot of them on a truck. There was Basalt International shipped a bridge from Maine to Florida, fabricated here in Maine. That's a 2-span bridge, about 55 or 56 feet long, each span, 2-lane bridge. The whole bridge was shipped on one flatbed, okay? Because the girders could nest together, they're light enough to do that. Now, if you try to do that with traditional materials, you're gonna need a lot more trucks, of course, to be able to do that. So you're reducing in essentially transportation costs, delivery costs, trucking costs. And then this whole superstructure was actually installed in less than half a day because this contractor would put them up 2 at a time. So it went very quickly. Now notice another thing, there's connectors on top of this. And these connectors are designed to be quick disconnect connectors, okay? Now, when we have steel girders, of course, we use welded studs, right? And what do you do after 40 years? What do we all do after 40 years when the concrete decks falls apart? We go with the big jackhammers. And how long does it take to actually do that and replace the jackhammer a deck off of a bridge? A long time. We shut down the roads and so forth. Well, we started thinking about, well, how can we do it so that our children and grandchildren don't have to jackhammer bridge decks? So we developed essentially a quick disconnect composite connectors that actually allows you to actually undo the connector. It's a composite connection that you can undo the bolt from under the deck, saw it cut if you wanted to in pieces and take it out. So instead of taking weeks, if not months, to actually jackhammer it, what about doing it in a few days? That's an example of some innovations that we're able to bring into the transportation infrastructure and systems. And the other big thing is maintenance costs. We all know that things corrode out there. You can put galvanic coatings, you can do all kinds of coatings, but they eventually corrode. So composites have an opportunity to really increase our life cycle, reduce our operation and maintenance costs, which are a big cost for DOTs right now, across not only in New England, but across the country, particularly where we use salts on the roads, particularly where we have, we're building bridges near saltwater environments. So this is where we hope to continue to work with all of you to bring these technologies into the civil infrastructure. So this is an example of a project done under the Transportation Center that we've had, that we're very excited about. Another example here is that we've worked with the Maine DOT. The Maine DOT have a lot of amazing and innovative folks that we've been working with. They came up to us and say, we're getting lots of floods. How many of you are getting more and more flooding right now, right, on the bridges? How many of you believe there's an increased number of extreme events right now? Okay, just about everybody's raising their hands. So what's happening? So what's happening is a lot of the culverts under our highways and roads are flooding under these events, and then they're washing out roadways. And when you're in a rural state like in Maine, if a roadway gets washed out, you may have to take a very long detour before you can come back to where you need to be. So the Maine DOT had an idea for actually to put a diffuser on this culvert. It's a diffuser that allows you to speed up the water flow through the culvert. It's formed as a cone shaped. It acts like a venturi that sucks water through the faster through the same cross section. So it's cone shaped, and then we at the University of Maine worked with them to figure out a way to 3D print essentially these culvert diffusers you can put at the end of a culvert and make the water go a lot faster. 30 to 40% more water can go through the same culvert. And 3D printing them, why? Because every culvert's different, right? It's very difficult to go out and figure out how to do that. We can go scan a culvert and then go out and 3D print, if you wish, a diffuser that allows you to go ahead and get more water through it. So when the next storm comes and the extreme storm comes in, you're less likely to wash out your road or your bridge and so on and so forth. Considering the cost of having to replace a roadway and the shutdowns and so forth, investing in culvert replacement or culvert diffusers like that in areas where you have some potential, some flooding issues that you've identified are prone to flooding or more prone to flooding, you can have a preventive maintenance program to go out there and put these 3D printed diffusers on them. And that's an example of a technology developed right here. People would think it's not possible. It is possible now. We can 3D print things to whatever geometry that's needed and fit a particular culvert geometry. So these are examples of technologies. And if you have time to go to the lab and see these things firsthand. Another thing we've worked on is 3D printed formwork for concrete. Oftentimes, the concrete structures in applications are complicated, and the formwork's very difficult to build. Not always difficult to build, but in some cases it is. So can you 3D print more cost-effectively formwork that you can pour concrete in and reuse the formwork over and over again? We've developed technologies to do that. These pieces were all working with the DOT here in Maine, were produced, cast into 3D printed formwork, okay? And the formwork were reused over and over again. Again, you can stick-built formwork. We all know we could do that. But when you have complex shapes of formworks, it may make sense to go ahead and 3D print them. And that's a way that we have technologies to do that right now. And the beauty of the formwork we build, after you've used it, 30 or 40 times, you can grind it back up and then put it back into the printer. We've shown that we can actually regrind the formwork and reprint it over and over again. We've done it 5 times. One of our students, her graduate thesis was grind it up and print again with it 5 times over and figure out how the properties change over and over again. So these are some technologies that were brought into play. Next, please. We've been looking at monitoring railroad bridges. This is with UConn. UConn has done a lot of work with us on monitoring railroad bridges. As you know, railroad infrastructure is also falling apart, and we've developed unique techniques to go monitor them. Next, please. We've also worked with the University of Vermont after the flooding they've had in Vermont, if you remember a few years ago, to figure out which regions of the state are more prone to flooding and identify those bridges and those locations. So they've done a network assessment of these. We've also worked with the University UMass Lowell. That bridge I showed you in Hamden, Maine, actually had sensing textiles built into the girders that can actually sense the stresses and strains. They're not strain gauges, but they work like strain gauges, but they're made with fiber optic sensors that are placed on the girders, and they can tell us over the long term how the health of these bridges. So there's new technologies to embed that, if you wish, and include that in bridge applications. Next, please. And finally, working with Western New England University, we've looked at ways to prevent stress-induced failures in pre-stressed concrete cross ties. As you know, pre-stressed concrete cross ties have problems and they fracture, and we've looked at ways to enhance them so we can have better cross ties. These are just examples of the kinds of projects that took place over the last few years. And the last project I'll talk about is more of enhancing the ecosystem around bridges and roads and so on and so forth. University of Rhode Island worked on an innovative pollinator plant that you can place in medians and highways to enhance, to reduce runoff and erosion and so on and so forth. So there's a variety of things we've looked at to try to enhance the transportation infrastructure throughout. You can go out and take a look at the exhibitors if you ask. There's a variety of exhibitors right on the other end. And next, please. And I'd like to thank our sponsors, which I've already done once. And next, please.